Hello, welcome. We'll be discussing a topic called pointers from Unit 2, and the topic that we are discussing now is pointers to arrays. So let's first try to understand the definition of a pointer and then also an array for us to start working with pointers and arrays. So what do you mean by a pointer? A pointer is a memory variable that stores the address of another variable. So a pointer essentially stores address. And what is an array? Array is a collection of similar elements. Array is a collection of elements of same type. So array becomes a collection of elements with a common name at different indices. They are stored in contiguous locations. So if the first element, if it is integer array, assuming that each element occupies 2 bytes, the first element is at 100, second element is at 102, third element is at 104, next element is at 106, next element is at 108, and so on. If it is a collection of 5 elements, if A is an integer array of collection of 5 elements, say for example int A of 5. So array is a collection of similar elements and pointer stores the address. So if I have a pointer P and if there is an array A, how do you access elements of an array? Using its pointer. So that is what we're going to study today. So let us start our discussion. And the first topic that we are going to see is pointers to 1D arrays. A one-dimensional array is a collection of elements. We have just seen in the previous example, if it is 100, it is 102, 104, 106 and 108. So imagine the elements are 1, 2, 3, 4 and 5, or 10, 20, 30, 40 and 50. Say for our convenience, let this be 10, 20, 30, 40 and 50. The elements are 10, 20, 30 and 40 and 50. So this is an integer array A. Declare a pointer P. So how do you declare a pointer P? A pointer P is declared using an indirection operator. So int star P. Now P becomes a pointer. In order to access the elements of a one-dimensional array using its pointer, the pointer also needs to start pointing the base address of the array. The pointer needs to hold the base address of 1D array. So here comes the question, what is base address? Base address of an array is the address of the starting element of the array. In other words, base address is nothing but the address of the starting element. What is the address of the starting element of an array? Nothing but the address of the first element. Where is the first element stored in an array? Obviously at A of 0. So therefore, the pointer needs to be initialized with the base address of the array. Once when the pointer is initialized with the base address of the array, the pointer starts pointing to star P, where P starts pointing to the base element of the array. And there is one feature of pointers which says pointers can be there is a feature of pointers which is incrementing of pointers. We all know that pointers can be incremented. So what does pointers can be incremented means? So a pointer will be incremented to point to the next element or next location. So therefore, when you write int star P is equal to ampersand A of 0, that is when it points to the first element, then if I write P plus plus, implies P is equal to P plus 1. It implies the base address in the previous case was 100, 100 plus 1, which is nothing but 101. No, it's not 101. It is, we all know, when the pointer gets incremented, it is P is equal to P plus 1 into something called as, we all have seen it, this is called as scaling factor. What is called scaling factor? Scaling factor is the value that is multiplied with the index, which is nothing but the size of the data type. So what is the data type here? The data type that we are talking about is integer. So the scaling factor for integer is size of int. Let us assume that it is 2 bytes. So it is 1 into 2 plus P. The base address initially was 100. 100 plus 1 into 2, which is nothing but 102. So when you do p++, the value that you get is 102. When you do p++, the value that you get is 102. So therefore, now let us consider this array. 10, 20, 30, 40 and 50. 100, 102, 104, 106 and 108. Name is A. 0, 1, 2, 0, 1, 2, 3 and 4. These are all the indices. So assume that P is a pointer that is storing the base address 100. So let us calculate P. We all know that P is equal to 100. P is a pointer, then star P gives nothing but its value. So the value at star P is value at A of 0, nothing but 10. So now let us do P plus 1. P plus 1 is nothing but 100 plus 1 into scaling factor. Scaling factor here is 2. So it is 102. And the value at star of P plus 1 is nothing but the value at star of 102. What is the value at 102? 102 is an address and the value at 102 is 20. So therefore, when you write P plus 1, you get the address of address 102, and when you write star of P plus 1, you get the value 20. So let us do it. Let us do P plus 2. P plus 2 is nothing but 100 plus 2 into 2, which is nothing but 104. What is the value at 104? Star 102, star 104 implies what's the value at 104? 30. The value at 104 is 30. So when you do P plus 3, you will get 106 and the value at 106 is 40. Similarly, when you do P plus 4, you will get 108 and the value at 108 is 50. This is how you can access the elements of a one-dimensional array using its pointer. So therefore, finally, conclude by writing, if P is a pointer to a one-dimensional array, if P is a pointer to a 1D array, then star of P plus I will give you the value at A of I, and P plus I will simply give you the address, nothing but ampersand A of I. So if this logic is remembered, then it is pretty easy for us to immediately, just run any kind of program with arrays using pointers. So if P is a pointer to a one-dimensional array, then star of P plus I will give you the value at A of I, and P plus I will give you the address, that is ampersand A of I. So in this case, let's take up a simple C program and try to run and see pointers to 1D arrays. So this is a program that takes in C pointers to 1D arrays. So I have a array A in star P, a pointer, and an array A of 5 elements. So I just took it for a simple example as 5 elements. You can have some 10 elements as well. So clear screen, enter 5 elements. For I equals 0, I less than 5, I plus plus. We have just learned that P plus I is nothing but ampersand A of I. That's what we have seen. P plus I, instead of ampersand A of I, we got to write P plus I. Instead of A of I, we got to write star of P plus I. So very simple logic. You just need substitution. So therefore, instead of here, what do we write as ampersand A of I? Instead of that, you write star of P plus I, where I wrote P is equal to A. So P is equal to A, or you can also write P is equal to ampersand A of 0, which is the base address of the element. So I wrote P plus I. Then how do you print it? For I equals 0, I less than 5, I plus plus, value of A of 0 is equal to percentile D. Is at A of percentile D. This is what we have been writing. A of I is the value, which is also nothing but star of P plus I. That's what we have seen. A of I is nothing but star of P plus I. So A of I is star of P plus I, and ampersand A of I is nothing but P plus I. So therefore, save your program, compile, and run. Enter 5 elements. My elements are 1, 2, 3, 4, and 5. Enter. So please check out, I used percentile U to print the address because addresses are positive numbers, unsigned numbers. The other way of printing address is percentile P, which can also be used. So percentile P prints it in hexadecimal notation. I just used percentile U to clearly show you the difference. My computer integer is occupying 2 bytes, so therefore I got 16. 655, 16, the next element is at 18, the next element is at 20, next element is at 22, next element is at 24. This is clearly enough for us to show that elements of an array are stored in contiguous memory locations. You can also observe this: A of 0, A of 1, A of 2, A of 3 and A of 4. So with this example, it is easy for us, or we can clearly show that this is how you can access elements of a one-dimensional array using its pointer. Another thing to mention here is, my dear students, the base address of an array is also, in C, the base address of an array, which is nothing but ampersand A of 0, is also stored in the name itself. In other words, the name of the array itself is a constant pointer pointing to the first element of the array. The name of the array itself is a constant pointer pointing to the first element of the array. So array name A will itself store ampersand A of 0. So instead of writing P is equal to ampersand A of 0, we can also write it as P is equal to A. And instead of writing star of P plus I, many a times you can simply write it as star of A plus I. And instead of writing P plus I, we can also write it as A plus I, and you always get the same answer. If you want to confirm, let's just redo this program and replace all P's with A's and check out. So because we wrote this one, let's do this. So I will just replace P with A and check out if this is working or not. So I've just kept it as P itself. So this part we'll check out and see. Star of P plus I. Instead of P plus I, P, which is the pointer, I've used A plus I because the array name itself is a constant pointer pointing to the first element of the array. So on this note, save. So for much more things, we'll even take this as P is equal to A. This is other way of doing because array name itself is a constant pointer. Compile and run. Enter 5 elements, 1, 2, 3, 4 and 5. Yes. You got the same answer what you got in the previous case. 14, 16, 18, 20 and 22. All elements in a similar location, and this is how you tend to get your answer. So therefore, it is enough to show that P is equal to A. The name of an array itself is a pointer that stores the base address of the array. So from now on, ampersand A of 0 can be treated as simply A. And if that is given to a pointer, you can write either P is equal to A, or you can also write P is equal to ampersand A of 0 for a one-dimensional array. So this is about pointers to one-dimensional arrays. And before closing, let me make a small note. My dear students, it's not very difficult to write any program using pointers, especially array program using pointers. There is a misconception among all of us. Where am I supposed to write? How am I supposed to write? How do I make a program using pointers? So the only thing I say is you write down your entire code using arrays, because all of us by now are familiar using arrays. So in any case, say for example, swapping in a bubble sort. So you write T is equal to A of J. What do you write in a bubble sort? A of J is equal to A of J plus 1. A of J plus 1 is equal to T. This is what we write, right? So if I want to rewrite this program using pointers, then the easiest way of writing is I write T is equal to A of J. You now want start writing it as star of A plus J, because A of I is nothing but star of A plus I. We have just seen. So then I write A of J. How do you write A of J? Nothing but star of A plus J is equal to, how do you write A of J plus 1? Star of A plus J plus 1. And how do you write A of J plus 1? Star of A plus J plus 1 is equal to T. So I just wanted to conclude this by telling you that any time whenever you are asked to write any logic of a one-dimensional array using a pointer, just write down your array logic, replace all A of i's with star of A plus I and A of j's with star of A plus J. And that's an easy solution for any problem that you want to code. Good day.